Hello all, I'm Munther Hindi. I'm going to present an introduction to the FreeCAD GDML workbench. This is a tool written by Keith Sloan to import and export GDML files in FreeCAD. Keith is the project maintainer. I've been contributing to this project for the past 2 years. GDML stands for Geometry Description Markup Language. This is a specialized XML-based language for describing the geometries of detectors for physics experiments. A GDML module has been integrated into GEANT4 since release 9.2. If you are compiling GEANT4, then you might need to set the GEANT4 use GDML flag to true. The GDML workbench is a tool for importing GDML files into FreeCAD and exporting FreeCAD geometries to GDML. Here is an abbreviated look at a GDML file. It starts with a define section that introduces named constants for subsequent use. Then there is a materials block that contains the definitions of all the materials that will be used. The solids block defines all the solids that will be used in the geometry. GDML defines about 30 different solids. In addition, one can define a solid as a Boolean of previously introduced solids. The structure defines the geometry tree. It defines volumes, which are solids plus their corresponding materials, and placements of these volumes in previously defined volumes. And finally, the setup defines the top of the tree. FreeCAD is an open source CAD application. Binaries are available for the Windows, Mac, and Linux operating systems. One can also build the app from the source code, all available from freecad.org. Here are some features of FreeCAD. The kernel is based on Open Cascade. Solids can be defined in terms of basic primitives such as spheres, cylinders, etc., and booleans of those primitives, or as boundary representation, or as non-uniform rational basis splines. Object properties and placements are fully parametric. That is, one can define the properties of one object using mathematical expressions that make use of the properties of other objects or of named cells in a spreadsheet. Although the core functionality of FreeCAD is written in C++, access to this functionality is available through an extensive Python API. The GDML workbench is written completely in Python. FreeCAD also supports a large number of CAD file formats. Some of them are listed above. What's more important for us is that add-on workbenches can add new file formats. Our GDML workbench adds support for importing and exporting GDML files. Another important feature of FreeCAD is its parametric, constraints-based 2D sketcher. Say one circular arc can be constrained to be tangent to another. If the first arc is changed in any way, the unconstrained properties of the other changes to maintain the tangency. One can build solids from sketches by extruding them, revolving them, or sweeping one sketch to another along a path. From a user's point of view, the functionality of FreeCAD is accessed through workbenches. A workbench is a set of tools and GUI grouped together for a specific task. A workbench can be selected from a drop-down list of available workbenches. Base workbenches are installed with FreeCAD and maintained by its developers. External workbenches are developed by the community and have to be manually installed. The GDML workbench is an external workbench. Note that it is common to use more than one workbench in the course of building a FreeCAD document. For example, one might use the part workbench to add basic CSG objects, then use the gears workbench to add gears, to the same document, then use the Fasteners workbench to add ANSI nuts and bolts to that same document. Installing external workbenches is quite easy. Select the add-on manager from the Tools menu, then select the needed workbench from the list that FreeCAD fetches online. In this presentation, I will concentrate on going from FreeCAD to GDML to GEANT, the workflow shown here. But one can also go from GEANT4 geometry, built using say C++ or read from a text file, to FreeCAD. The GEANT4 example G01 shows how to read and write GDML files in a GEANT application. Here is a mini tutorial on how to create a GDML file from scratch in FreeCAD. First, launch FreeCAD, obviously. Then, while in the Start page, select the GDML workbench from the Workbenches menu. And click on Create New. A document will appear with all the GDML workbench tools. The document will be pre-populated with an empty world box. Next, add one of the predefined GDML solids. Here I show a GDML sphere added to the document with some default parameters. The default parameters can be changed by clicking on a property and entering a new value. Note that the GDML solid, quote-unquote, added to the document is an object that, in addition to its shape properties, has a material property and a placement, that is, a position and a rotation property. So the element added to the document tree results in a solid, a volume, and a physical placement in the exported GDML file. The material property of the GDML solid can be changed in one of two ways. First, by clicking on the material property and selecting from a drop-down list of all the available materials. Second, by using the Set Material icon. This allows a faster selection than moving through the long drop-down list by doing an incremental search based on the first few characters of the type name. When a new document is created, a file supplied with the GDML workbench called GEANT4materials.xml is loaded. This file contains the GEANT4 and NIST list of materials. The materials are displayed as a group with subgroups in the FreeCAD document. At present, new materials cannot be defined from within the GDML workbench. New materials, however, can be added directly to the supplied file or read by opening or importing a user-supplied GDML file. Opening a GDML file creates a new document. Importing it adds its contents to the currently open document. In addition to adding base GDML solids to the document, one can add booleans, that is, cuts or intersections or unions of two shapes that are already in the document. To add a boolean, select the two solids in the document tree, then click on the icon for the desired boolean operation. Here we show a box cut by a tube. The final step in creating a GDML file is to export the world volume. First, select the world volume, then select File, then Export from the top level menu. In the Export File form, select GDML for the filter. There are two entries with GDML. The one that exports to a lowercase GDML extension results in the whole document being exported to a single GDML file, while the one which results in an uppercase GDML extension exports to a directory with separate GDML sections as includes. The exported GDML file can be viewed and tested from within GEANT by using the application Load GDML. This application is supplied as an example G01 in the GEANT4 distribution. The GDML workbench exports the FreeCAD color of each solid by adding an auxiliary tag to each exported volume in the GDML file. To process the OX-type equal color tag, we have a modified version of LoadGDML called LoadGDML color that processes the color auxiliary tag. We can add the modified C++ file to the GDML workbench GitHub page if there is interest. The screenshot shows the LoadGDML color application with the file exported above loaded. The utility of the GDML workbench is enhanced substantially by allowing the export of other FreeCAD non-GDML solids to GDML. One item is extrusion of an arbitrary sketch. This can all be done from within the GDML workbench or by using a combination of the part and sketcher workbenches. First, click on the sketcher icon in the GDML workbench. Second, build a closed sketch, that is one where each of the curves making up the sketch is a closed curve. Then close the sketch. This screenshot shows a sketch made up of many of the curve types available in the sketcher workbench, namely circle, ellipse, circular arc, elliptical arc, B-spline, parabolic arc, and of course you could add simple polygons. Then select the sketch in the tree and extrude it to the desired height by using the extrude icon. Then add a part to the world volume or any subpart by clicking the Add Part icon. Then drag the extrusion object under the added part. To the extent possible, extrusions are exported as booleans of GDML solids. For example, a circle extrudes to a tube, a polygon extrudes to a GDML extrude, an ellipse to an elliptical tube, etc. We believe this produces faster GEANT4 simulations than simply converting the resulting extrusion to a tessellation. To test this, we have compared the time for GEANT simulations with the shown extrusions exported as booleans of GDML solids versus exporting them as tessellations. In a simulation with 10 to the 6 GEANTinos, the extrusion export was about 2.4 times faster than export as a tessellation. With 10 to the 6 2 MeV gamma rays, the extrusion export as booleans was about 8.4 times faster than the export as a tessellation. Obviously, this is not a comprehensive study, and the speed gain will depend on the particular geometry and particles. Another useful object that the GDML workbench adds direct support for is a revolve of a sketch. To create a surface of revolution, enter the sketcher, create a closed curve or a series of curves, close the sketch, and then create a revolve using the shown icon. Revolves are exported as booleans of GDML generic polygon. Here we show a closed curve in the sketcher, the resulting revolve in FreeCAD on the left, and a view of the GDML file in GEANT4 on the right. In FreeCAD, one can construct arrays of a base object. The GDML workbench allows the export of these. One type of array is an orthogonal array, where the object can be repeated in 3 dimensions. To create an array in the workbench, select the object, then select the orthogonal array icon and enter the number and spacing of the object in each dimension. Arrays of an object are exported as GDML multi-unions and will all have the same material. An example is shown in FreeCAD on the left and as viewed in the GEANT4 app on the right. Another type of array is a polar array, where the base object is repeated uniformly along a circle or a circular arc. On the right is an example as it appears in FreeCAD, and on the right as it appears in the GEANT app. Another potentially useful type of array is the uniform distribution of a base object along a path in 3D. To build such an array, construct the curve in FreeCAD, select it, select the base object, and click on the path array icon. The example here shows an array of cones along a helical path. The view in FreeCAD is on the left, and a view of the exported GDML file in the GEANT app is on the right. Another type of array is a point array, where an object is placed at an arbitrary set of points. An example is shown in the extra slides. Any solid that can be exported to GDML by the workbench can serve as the base object of an array. Since an array exports to a single multi-union solid, it can also serve as the base of another array, and hence one can have arrays of arrays. This example shows an orthogonal array of a polar array of a cut of a box with a cylinder. On the left is the view in FreeCAD, and on the right a view of the exported GDML file in the Load GDML app. There are a variety of other shapes that one can build in FreeCAD that the workbench currently cannot export as booleans of the GDML base shapes. Examples are fillets and chamfers. Although these can in principle be built using booleans, we do not have support for them in the workbench. However, just about any closed shape can be exported by meshing it and then exporting the mesh as a GDML tessellation. There are commands in the GDML workbench for meshing objects, but the Mesh Design workbench offers many additional tools for meshes. Here is an example. One can use the part workbench to generate a sweep by taking two sketches and sweeping from one to the other continuously along a path. If the curves are closed, one can generate a solid this way. If the curves are open, one can generate a surface. Here we show a circle swept to a square along an arc of a circle. The sweep shape can be converted to a tessellated solid using the part to mesh command in the GDML workbench or in the Mesh Design workbench. The result, as seen in FreeCAD, is shown in the middle, and a view of the exported GDML file containing the tessellation is shown on the right. The GDML workbench also supports assignment and editing of optical surfaces to objects. With the GDML workbench activated, open a new document. The GDML document structure will include two empty groups related to opticals, a matrix group and a surface group. The matrix group can be filled with optical properties by opening an XML file containing these. An example called matrix.xml is provided in the resources with the GDML workbench. An example file with optical properties called optical.xml is also provided. Import that as a base for optical properties. There are two commands for adding optical properties, the skin surface command and the border surface command. Installation requirements for the GDML workbench can be found on Keith's GitHub page. Address is shown below. Use instructions and examples and several sample files can also be found on the GitHub page, and there is a wiki page that describes the use. Future of the workbench and some items on our to-do list. 1. A variety of command line scripts that bypass the FreeCAD GUI. Second, as I mentioned before, currently new materials cannot be built in the workbench. We would like to be able to provide a GUI for constructing new materials. Third, although all of the solids defined by the GDML manual, 30 with variants of some, have Python implementations, we have not included commands, i.e. icons or menu items, to add all of those to the document. Next, FreeCAD can check overlap of shapes. We actually make use of that when constructing arrays of solids with optical surfaces. It would be nice to add a facility for flagging objects that do overlap in FreeCAD. Currently, if a FreeCAD document is exported as GDML and the GDML is read back into FreeCAD, one does not get the exact same document that was exported. For example, an array is exported as a multi-union, but when read back, it is read back as a multi-union, not as an array. It would be nice to get a closer match between the exported FreeCAD document and the imported GDML file. And finally, and for me most importantly, we really need help in maintaining this project. Both Keith and I are in our early 70s and probably cannot continue to maintain the project far into the future. We would like to get younger people who are competent in Python involved in the project with a view to eventually handing over the project to one of them. We are willing and would be happy to mentor anyone who is interested. In addition to the people listed here who contributed directly to the project, we have benefited greatly from suggestions and bug reports from many users of the workbench. Their names are listed in here and on the GitHub page. Geometry in both FreeCAD and GDML is hierarchical. That is, objects can be placed inside other objects. The correspondence between the FreeCAD hierarchy and the GDML hierarchy is shown here. A mother volume, an app part in FreeCAD parlance, can contain daughter volumes by assigning a containing solid to the mother volume. The resulting structure of the exported GDML file is shown in the top panel. Another type of containment is an assembly. This groups objects that need to be placed or rotated together. In FreeCAD, this is achieved by creating an app part, the yellow icon, and placing more than one solid underneath that part. The resulting structure in the GDML file is shown in the bottom panel. Arrays of a base solid can be placed at arbitrary points. The points can be specified in a variety of ways in FreeCAD. The points workbench can read files that give point locations in a variety of formats. An example in FreeCAD is shown on the left, and the corresponding view of the GDML file is shown on the right. Mirrored objects can also be exported by the GDML workbench. They are added by selecting the object, a reflection plane, and executing the mirror command. An example is shown here.